Okay, so basically how we can define the matrices, there are the ways, and that ways are same as the your rule, right? The first is रो मैट्रिक्स आप बना सकते हैं. You can create that one by using curly bracket, and you can put all the elements in the curly bracket and separated by comma. The rule is same, right? So you can see here I have created one matrix, row matrix A. So basically that is 1 2 7 9, and your output will be like this one. So if you want to retrieve any element from this particular row matrix, way of doing it is that you have to put your name of the matrix. I have designed the capital A as my matrix, and the 2 times square brackets is needed, right? Remember this always whenever you are accessing the element for a particular matrix, whether it is a one-dimensional matrix or the two-dimensional or other dimensional, then you have to just put it position in the square two times square bracket. So remember this part. Okay, so here is an example. I want to retrieve my third element of this matrix, that is 1 2 3 4. So we have 4 elements in our row matrix, and the third one should be 7, and then you will get output as 7. Okay, now come to the 2D list. So for 2D list, what you can do, the rule is same. You have to create a list first. So here we have the one list. The first curly bracket is starting here, the first curly bracket ending here, right? And these are the elements. So we have 3 elements, and all 3 elements are list itself. So that means to creating a 2-dimensional list, you have to put 1-dimensional list as element of a list. So 2 times curly bracket shows you 2-dimensional list. So you have to start with the curly bracket, then first row of a matrix like this one. You have output 1 2 3, that is first row. So put curly bracket and 1 2 3. The rule is same, curly bracket, elements separated by comma. Remember always this. Then again comma, second element is our second row, 4 5 6 like this one, then comma, then the third row 7 8 9. So you can create in this way 2D list. In the same way, if you want to work for third dimensional or fourth dimension, you can create element, but the showing of that matrix may be some kind of in a different way, because we can work only graphically 2D, right? Because our laptop, our system, our desktop is on 2D systems, right? So that's why. Another function is very important here, that whenever you will execute this, like this one, so you executed A here, and the output is same as the list as you have entered. So whenever you are creating one matrix, the output will be same in the curly bracket. But if you want to come out with the standard form of a matrix, right? जैसे हम मैथमेटिक्स में नॉर्मल वे में हम लिखते हैं मैट्रिक्स को. So that is our notation, that you have to put some bracket and then you have to put element some particular position. So that is our matrix form, right? So the name is matrix form, M capital F capital, and you can put your name of the matrix in the input in the square bracket, right? Then this name will create you this particular output. So whenever you want to show for example, you want to show the users that they have working on some particular matrix, and the matrix should be come up with your standard form. So that will be your answer, that you have to use matrix form function or symbol, right? So how you can retrieve the element of 2D, the same rule is applied here also. Now you can see the matrix name with the 2 square bracket, like this one, 2 square bracket. Here was position, right? 1D you have index, first element, second element, third element, fourth element, right? But in 2D you have this one is your first row, first column. This one is first row, second column, first row, third column. So that means you have to specify the row position and the column position. So like this one, put all the positions in your row and column. So like here you can see that B, the third means the second row and third column. So that is our second row, and the third column is this one. So the element should be 6, and then you will get your answer. So I hope now it is clear to you that how we retrieve the element of a one-dimensional or two-dimensional matrix or list or 2D list. The same name is there. Okay, now you can do the matrix addition or subtraction by using your plus or minus. So same arithmetic operator as you use for any symbol, the same is work for matrices, but the condition is the order should be same, right? Order should be same as you need that particular condition in your mathematics also. So that's the rule is same. So a plus b will come out like this one. So a is 2d, and that is order 2 by 2. That is 2 by 2 because row is has two elements, right? This row has two elements, so that is 2 by 2 into 2 by 2. So you can get your addition. Same way you can go for your subtraction, a minus b, and you will get your answer. Okay, come to the next, the matrix multiplication. Now you should come up that, okay, we are using plus minus as a same arithmetic operator, then multiplication will also work. No. For matrix multiplication, we need a row by column rule, right? In matrix multiplication, we need row by column rule. So this rule is particularly created with the use of dot, not star, asterisk. So not use asterisk, just use dot for your matrix multiplication. So you have to put a dot b and you will get your answer. After that you can put matrix form. This one is your previous output. What is your previous output? The previous line, that is a dot b. So whatever a dot b will have, then you can put it in the standard form by calling matrix form function, and then you will get this one. In the same way, you can see here 3 by 3 matrix, 3 by 3 matrix, and you will create a dot b matrix multiplication, and you will get your answer in matrix form. So very simple and very easy functionality for doing matrices work in Mathematica. Okay, some different functions are also as in a built-in Mathematica. For example, you want to come up with the transpose, then the transpose word is there. The transpose, put your matrix inside, and the A is here now, this one, 1 2 3 3 4 7 3 1 2, and then you will get your this one. Now you can see I am not writing here matrix form, right? You have to write matrix form also to having this output. So remember always that I'm just writing transpose A. In the next line you have to put matrix form percentile, then you will get this output. So you can do inverse also. Direct inverse function is there, inverse of A, then you will get your answer. That is for determinant. So if you want to find out the determinant of A, so you have to just put det, det only, not the determinant, right? And you will get your answer. And another one is for TR, is for trace, right? So you can find out trace also, but only TR is used. So remember some functionality that the particular name is not as what we using as transpose, the complete word transpose, inverse, like this one. So here is det and TR. So you will get your trace. Trace is nothing but just you have to add the diagonal elements, right? 1 plus 4 plus 2, that is total 7. Then you will get your output as 7. Okay, and another function is that you can do the power of the matrices, right? So if you want to find out a to the power 3, so don't use a to the power 3 as in the arithmetic operator. No, it will not show up the same result, because a to the power 3 will create a star a star a. But what we want, actually we want matrix multiplication, so we need a dot a dot a. So remember this. So to creating output with 3 matrices, the matrix multiplication rule, you have to use matrix power function, not a to the power 3. This will do the component. जैसे कि यहाँ पर अगर आप देखें ये 1 3 3 है, सो अगर मैं इसका पावर 3 करूंगा तो ये एलिमेंट का पावर 3 करेगा सिर्फ. So 1 की पावर 2 की पावर 3, like this one. So 1 3 to the power 3, that will be 27 like this one, then 8, then 64, then 1. So this will be your answer for a to the power 3, right? Not a dot a dot a. तो आप दो तरीके से कर सकते हैं, या तो आप a dot a dot a यूज करिए, या फिर आप मैट्रिक्स पावर को यूज कर सकते हैं. आई होप नाउ दैट इज क्लियर टू यू दैट यू कैन यूज मैट्रिक्स पावर टू generate your power for particular matrix. And the next is you can also create identity matrix. So the name is same as identity matrix, and you can give the order for what order you want your matrices. So I have given here 3, so that is 3 by 3, and the identity matrix is created, right? Another one is the diagonal matrix. You can create diagonal matrix also. So that means you have to put elements in the diagonal only. So what you can do, you can create a list. Okay, remember now I am talking about list, right? Just put the list of the elements. So जितने भी diagonal elements आपके पास हैं like 1 2 3, उनको आप एक list में डाल देंगे और वो input बन जाएगा diagonal matrix function के लिए. So that means curly bracket 1 comma 2 comma 3, then curly bracket end, it will be the input like this one, and you will get this output. Another is you can find out the dimension for your matrix also. So whatever I have matrix A, and I will get the dimension. And now you can see the dimension output is in list also. So इस output को आप store कर लीजिए, और जो आपका पहला element है वो आपका row हो जाएगा और second element आपका column हो जाएगा. So वहां से आप retrieve कर सकते हैं. Now you know the rule of retrieving. तो इसको मैं dimension को suppose D, small d में store कर लूंगा, तो मेरा D में ये list आ गया है. So D का first position will be row and D का second position will be 3, like this one. I can retrieve the value. Okay, come to the table function. So what a table do? So basically generates a list of the values for a given range. So आप क्या कर सकते हैं, टेबल में किसी भी पर्टिकुलर फंक्शन के लिए एक पर्टिकुलर रेंज के लिए एक लिस्ट क्रिएट कर सकते हैं. सो टेबल आपका लिस्ट क्रिएट करता है, और ये लिस्ट सिर्फ ऐसा नहीं कि वन डायमेंशनली करें, नहीं, आप 2D कर सकते हैं, आप 3D कर सकते हैं, 4D कर सकते हैं, जितने भी डायमेंशन आप चाहें उतने ही वेरिएबल के डिपेंडेंट आप अपने लिस्ट को क्रिएट कर सकते हैं. ओके, लेट्स स्टार्ट विद द फर्स्ट वन. द टेबल इज, now you have the function here I to the power 2, and you are giving a range I 1 10. This is the same as like command as your plot, right? Plot I square and I range is 1 to 10. The same command is there, function is there, and the range is there, right? So you will put table function I square and the range for 1 to 10, your all the list will come up here. For I1, I square is 1. For 2, I square is 4. For 3, I square is 9, like this one. For 10, it will be 100. So that means I don't need to create a list manually. If you are have some particular list, that means which has some order, right? It has some order, no? Because every element has its square, so that particular order is defined for elements. That's why you can create by using some particular function. Another one you can see here we have a plus b, and the range for a is 1 to 10, for b is 1 to 5. So what we can do, for a it will go from 1 to 10, for b it will go for 1 to 5. So now you can see that there will be how many elements, can you tell me? So now you can see for A1, whenever I will put 1 here, A1, the B will vary, right? So for 1, so then first list will come, 1 is here fixed, and then vary the B variable for 1 to 5. So it will be 1 plus 1, then 1 plus 2, then 1 plus 3, then 1 plus 4, then 1 plus 5, like this one. Then you will get this element, first element. Similarly, for 2, A fixed 2, then vary the B, then you will get 3 4 5 6, like this one. Then you will get many elements. I have not written all the elements here, there are only 3 elements, so I am showing just for 3. But if you put all the elements, let me go to the exercises, so I will show you this one. Like this one, I have written only for 3 and 5. Okay, let me give you the for 1 to 10 here. Let me zoom it. ओके, सो आपका ये आउटपुट वैसे ही बढ़ जाएगा, ये देखिए, ठीक है ना? सो दैट इज फॉर A1, A2, A3, A4, A5, A6, A7, A8, A9, A10. दैट मीन्स फॉर रोज you have fixed the values of A, and you are varying before B, that is 1 2 3 4 5, and you are putting the elements as A plus B. So you can create as many as matrices you want. So that is easy, very easy, right? Okay, come to your table function here. Okay, the second thing is good about the table function is that you just not need to create only the list, but also you can use table function to create the list of plots also. See, it's not necessary you have to put the elements only, you can put plots also. So now here you can see what I'm doing, I am putting the plot function in my function here, then comma, I am giving the range for x 0 to 5. So that means that is a complete plot function here, plot sine x to the power n for 0 to 5, and after that comma, then I am giving the range for this n, that is 1 and 2. So that means you will get two function x sine x to the power 1 and sine x to the power 2. So that is the plot for n is equal to 1 and that is the plot for n is equal to 2. Then what I'm doing, I'm using table outside. So that means list will be created. So why we calling as list? Because curly bracket is there, right? In the starting, you can see curly bracket here, and the two plots are in your table. So you can create a list of plots also. So you can put elements, you can put solutions also in your table. So basically table will create a list for you. Now you can put elements or plots or some particular solution inside it. Come up with the solve function. Okay. Solve is very basic function for your equation or your system of equation or inequalities. You can solve these in your solve function, right? So you can come here with this first example, solve, and I have given the input as my first input is as equation. Now remember this, whenever you want to add one equation, so please see this symbol. Now you can see this one, this is not equal, it is equal to. Remember this? 2 times equal means equal to operator 2 times, not 1 time. Whenever you will put 1 time, it will give you some kind of syntax error. So please remember always this, whenever you are putting equation in your functions, maybe in solve, nsolve, dsolve or ndsolve, you have to put equal to operator, right? Okay, come to the next input is your x. So that means for what variable you want to solve, first input will be your equation or system of equation. Whenever you want to put system of equation means you have to put all the equations with the and operator like this one here. Okay, so let me complete the first part here. First example, solve this equation with the x variable and you will get your answer. Now you can understand what is this one. This is 2D, right? 2 curly bracket is in the starting, that means 2D list. And what is coming up, that is the rule. जब भी आपको इस तरह का मिले ना, x is tending to 2, x is tending to 3, तो इसका हम नाम मैथमेटिका में बोलते हैं रूल, RULE, नॉर्मल. सो दैट इज द रूल. रूल मीन्स कि x इज आपको टेंड कर रहा है 2 को, जैसे कि आप नॉर्मली कैलकुलस में यूज करते हैं, लिमिट के लिए यूज करते हैं, x इज टेंडिंग टू 2. सो दैट मीन्स द वैल्यू फॉर द x इज 2, x इज 3. सो आउटपुट आपका हमेशा रूल के फॉर्म में आएगा सॉल्व के लिए. तो ये थोड़ा आप समझ लीजिए, ये रूल हम बोलते हैं. बाद में हम इसका पर्टिकुलर वैल्यू को उठा सकते हैं यहाँ से, वो भी हम आगे सीखेंगे. Okay, so you can solve equation. Now come up to the this one. Here we have two equation, a plus b equal to 3 and a minus b equal to 1. So put first equation and that is and operator, right? Logical operator is there. Why and we need? Because all the values should be true. When whatever solution will exist, both the equations should be satisfied, right? That is the main purpose. So if you have two equation, if you have some solution, a is 2, b is 1, then this particular solution not just satisfy the first equation, but also the second equation. So that's why the AND operator, logical operator should be true. That this equation should be true, this equation should be true, then the total system will be true. So that is the reason why we are using this AND operator. I hope this is clear to you. Okay, come up this one. Here we have x square plus y square equal to 1, and that means second equation, x plus y equal to a. And now you have two variables like this one, a, b. You will solve here for x, y, and you will get your answer like this one, x, y, x, y. So now you can see here we have all 2D also. The first element is this one, x comma y. The second element also is this one, x comma y. So two solutions will exist because this is your second order polynomial equation. That's why. Okay, come up to this one, this equation. First understand the solve and then why we need use reduce function. So first see the solve. So you have solution for x square plus y square equal to 10 and x is greater than 0 and y is greater than 0. Then you will get this answer, right? Whenever you will do solve for this system, you will get this one. So what you are actually getting, you are getting some conditional expression for your range, because इस यहाँ पर आप देखिए आपके पास टू वेरिएबल्स है, राइट? सोल्व आप कर रहे हैं टू वेरिएबल्स में, x में और y में, लेकिन आपका इक्वेशन सिर्फ एक ही है ना? तो एक इक्वेशन आपके पास है, जबकि आप यहाँ पर टू वेरिएबल्स के लिए सोल्व करना चाहते हैं. तो रूल तो ये कि टू वेरिएबल्स के लिए टू इक्वेशन होना चाहिए, जैसे कि हमने पीछे किया है. यहाँ पर a प्लस बी है तो दो इक्वेशन है, यहाँ पर एक्स वाई है तो दो इक्वेशन है. दैट्स व्हाई वी आर गेटिंग सॉल्यूशन. बट इस केस में यहाँ पर सिर्फ एक इक्वेशन है, और ये तो सिर्फ कंडीशंस हो गई आपकी x के ग्रेटर देन होने की और y के ग्रेटर देन, बट इक्वेशन आपको उस तरह से नहीं मिल रहा है जिससे कि 2 हो या 3 हो, उस तरह से आपका सॉल्यूशन एग्जिस्ट करे, देन यू विल गेट सम टाइम ऑफ एक्सप्रेशन, और इनको हम बोलते हैं क्वांटिफायर्स, राइट। मैथमेटिक्स में, डिस्क्रीट मैथमेटिक्स में हम ये वर्ड क्वांटिफायर बहुत ज्यादा यूज करते हैं। क्वांटिफायर्स होते हैं आपके, जैसे कि आप नॉर्मल लाइफ उसमें कैलकुलस में या रियल एनालिसिस में यूज करते हैं, फॉर ऑल एक्स देयर एग्जिस्ट समथिंग, फॉर ए गिवन समथिंग यू आर टू डू समथिंग। सो क्या बोलते हैं, क्वांटिफायर हम उनको बोलते हैं। सो वो क्या होते हैं, वो एक्सप्रेशन होते हैं जो आपके मैथमेटिकल लैंग्वेज को सॉर्ट करके आपको बताते हैं। तो यहाँ इसने क्या लिखा है, इसने कंडीशनल एक्सप्रेशन का मीनिंग आंसर में क्या दिया है कि 10 माइनस एक्स स्क्वायर दैट इज योर y की वैल्यू आएगी आपकी 10 माइनस एक्स स्क्वायर। इक्वेशन से भी क्लियर है, मैं यहाँ पर y की वैल्यू 10 माइनस एक्स स्क्वायर ही आएगी, बिल्कुल करेक्ट लिखा हुआ है। और x की जो रेंज है वो x की रेंज आपका 0 से √10 तक जाएगी। तो ये इसका सॉल्यूशन है x के लिए और y के लिए। तो ये डिपेंडेंट है इस कंडीशन पर, y का जो सॉल्यूशन है वो x पे डिपेंड है, दैट मींस y इज अ फंक्शन ऑफ x एंड द रेंज फॉर द x इज 0 to √10। सो इस तरह का एक्सप्रेशन आपको आएगा। अगर आप चाहते हैं कि मेरा जो आंसर है वो इस तरह के एक्सप्रेशन में या क्वांटिफायर्स के साथ में ना आए, देन वी हैव टू यूज रिड्यूस फंक्शन। तो सोल्व के अलावा आपके पास एक फंक्शन ऐसा भी है जिसमें आप क्वांटिफायर्स को एलिमिनेट कर सकते हैं। तो देखिए, तो फंक्शन बिल्कुल सेम आपका वर्क करता है, सॉल्विंग इक्वेशन और इनइक्वालिटीज फॉर वेरिएबल्स। तो सो क्या करता है, ये स्टेटमेंट्स को रिड्यूस कर देता है और उसके एलिमिनेट करता है क्वांटिफायर्स को भी। सो द योर आंसर विल बी लाइक दिस वन। सो आई होप ये दोनों कंपैरिजन आपको क्लियर हो गया होगा कि अगर आपके सोल्व के अंदर, या फिर सोल्व कभी कभी क्या होता है, बहुत सारे इक्वेशंस आप अप्लाई करते हो सोल्व में, लेकिन वो लिख देता है वहां पर कि सोल्व कांट डू दैट, यू हैव टू यूज रिड्यूस। तो तुरंत वहां पर आपने सोल्व को हटा के रिड्यूस लगा देना है एंड यू विल गेट योर आंसर लाइक दिस वन। कम टू द नेक्स्ट, here you have reduced x square minus y cube equal to 1, and the variable are your xy, then you will get your answer like this one. So you can do as many as the reduce the system of equation. Here the last one, x square minus 7y square equal to 1, and that is the second equation, or you can use your conditions, that is the variable condition. So all will be counted as equation. So and x greater than y and y greater than 0, then comma, then range, and you can put your domain also, right? Integers or reals like this one. So you can put your domain also, and then you can reduce your system, or even you can solve for particular domain. Solve में भी आप ये चीजें लगा सकते हैं, integers, reals like this one.